Hello Year 9s, welcome back. What I'm gonna do in this next video is go through the next section in your Learning from Home booklet. In this section, what we're going to be doing is looking at finding the length of shorter sides in right angled triangles using Pythagoras Theorem. Now, in last lesson, we looked at this thing over here that's on the screen right now. We use Pythagoras Theorem to help us find the length of the longer side, the hypotenuse, or that side over here in the light blue, that C side, by using these steps that we have on the screen. So these are the 4 steps that we used. The first step was we wrote Pythagoras Theorem. We wrote C squared is equal to A squared plus B squared. We substituted the values of the shorter side. So we found the length of the shorter side A and the shorter side B, and we substituted them in. Then we squared both those sides and added them together. And then we took the square root of this to get a final answer that we're looking for. That's what we did last lesson. In this lesson, what we're going to be doing is looking at finding the length of shorter sides. So with Pythagoras' theorem, we're dealing with right angled triangles. And you're not always going to be given a missing side as being a missing, the missing side being the missing hypotenuse. Sometimes you might be given a missing side being one of the shorter sides. For example, you might be trying to find A. So what we have here is when we're trying to find the missing side like A, instead of using the steps that we did in the previous part, we actually need to do an additional step. If you have a look here, I'm going to rearrange this equation so that I have A by itself on one side, and so we can be solving for A. What I'm going to do is I'm going to actually move this plus B over here to the other side of the equation. When I move a plus to the other side and becomes a minus, we actually have, when we move a plus to the other side, it becomes a minus. So here, what I'm going to have is, I'm going to have C squared minus B squared is equal to A squared. And what I'm going to do is I'm just going to rewrite it with A squared on the right hand side, on the left hand side I mean. I'm just going to rewrite this, and boom, here we go. So if we're trying to find A, what we have is A squared is equal to C squared minus B squared. Now what I need to do from there is, well, I don't want to find A squared. I actually want to find A, and so what I need to do is I need to take the square root of A squared. So here I'm going to have, I'll just copy it in. So I've got A is equal to the square root of C squared minus B squared. So here, instead of squaring and adding the sides together, we're actually going to square and subtract the two sides. So here are the steps that we're going to use instead. So here I'm going to scroll up. Now, what we have here is this first step is exactly the same when we're using Pythagoras' theorem with the hypotenuse. We write Pythagoras' theorem, we write C squared is equal to A squared plus B squared. The next thing that we do after that is then we rearrange. Well, we rewrite it so that we have it in that form that we have over here. We've got A squared is equal to C squared minus B squared. So here you just need to be very clear. C is your hypotenuse. You can't have it being any one of your other sides. C is your hypotenuse. Once we've done that, instead of squaring and adding, which is what we normally did, I'm going to erase that. We're going to square and subtract the two. So here we square and subtract because that is what the sign in between tells us that we need to do. And then after that, we square root it. So we take this thing over here. I'm just going to put it down in here. Oop. When we're trying to solve for A, we get rid of that square sign and we put a square root here. And so here we've got A is equal to the square root of C squared minus B squared. I would like you to have this copied down in your book so you have a reference of it, just in case you want to have, so that we can look back at it in the future. So can you please have this written down in your books for me, Year 9s?